All right, we're in section 6.6 right now, and we're going to start talking about solving rational equations. We've talked about rational expressions, simplifying, adding to expressions, subtracting to expressions. Let's talk about now what happens if there's an equal to sign and we actually want to solve for x. We want to solve rational equations. Now, rational equations have fractions of polynomials before and or after an equal to sign. And now because there are denominators and we are solving, remember that there are values of x that could cause that denominator to equal 0. And so we have to be careful on some of our domain restrictions. And so if we have a restricted value that causes that denominator to equal 0, we call that solution an extraneous solution. And so we have to first look to see what our domain restrictions are going to be anytime they're asking us to solve, and we have a rational equation with denominators, right? So look at these two problems here. If I have these two rational expressions set equal to each other and they ask me to solve, the first thing we need to do is figure out what x can't be. What are our domain restrictions? Well, if I look at this first denominator, what x is going to cause that denominator to equal 0? And when I look at the second denominator, what x is going to cause that denominator to equal 0? X can be anything except for the two numbers that are going to cause those denominators to equal 0, because remember, we can't divide by 0. And so any x should work except for x cannot equal -2 and x cannot equal 5. So we're going to solve these problems and then just make sure that our answer isn't -2 or 5. So that's the first thing we need to look at. If you look at the second one, we need to figure out what's going to cause each of these denominators to equal 0, since there's 3 denominators now. On the first one, x cannot equal -1. On the second one, I would have to factor that one a little bit into an x plus 4 and x plus 1, set them equal to 0, and I end up getting two other extraneous solutions where x cannot equal -4 and x cannot equal -1. Same solution over here. And in the last one, when I set that third denominator equal to 0, I end up getting x can't equal 0. So on this equation, after I solve it, I just have to make sure that x isn't -1, -4, or 0, and then I should be good. So anytime we have proportions, and what proportions are is when we have one fraction on each side of the equal to sign. What I can do first is always remember to list your restrictions. What are the domain restrictions? We can then cross multiply, and then we can solve the remaining equation. Look at example number 1a with me. I have two fractions set equal to each other, one on each side. So this is a proportion. The first thing I want to do, though, is figure out what my domain restrictions are. What can x not be? Well, if I take each of those denominators and set them equal to 0, I end up getting domain restrictions of 6 and -8. So I know x can be anything except for 6 and -8. So let's go ahead and solve this. Let's go ahead and solve by cross multiplying. I should be able to take the 2 and multiply it by the x plus 8, and I should be able to take the 6 and multiply it by the x minus 6, and I can set those two equal to each other. I'm going to distribute the 2 through, and I'm going to distribute the 6 through. And now I have an equation that I can solve. I'm going to subtract 2 to both sides. I'm going to add 36 to both sides. I end up getting 4x is equal to 52, and then I can divide both sides by 4, and I end up getting x equals 13. Now, double check that that answer makes sense and isn't one of our domain restrictions. And since our only restrictions are 6 and -8, then x equals 13 should work and be the correct answer for that proportion. Let's do another one. Look at b. I have two fractions equal to each other, so I have a proportion. Let's first look to see what our domain restrictions are. What x's are going to cause both of those denominators to equal 0? You should end up getting restrictions of -4 and 0. So any x should work except for those two numbers. Let's go ahead and solve this proportion by cross multiplying. We should be able to take the 3x times the x and set it equal to 2 times x plus 4. A 3x times x is a 3x squared. When I distribute the 2, I ended up getting a 2x plus 8. And now you notice on this polynomial, we have an x squared, an x, and a constant, a number. So none of those are like terms, but it looks like it's a quadratic, right? And so the only way that we can solve this quadratic is by factoring. So let's make sure that we follow the steps for factoring. Move everything to the same side and set it equal to 0. So I subtracted the 2x and I subtracted the 8 over. I can now factor. This one looks like it's a bottoms up factoring. So I'm going to multiply the 3 times the 8. I'm going to basic factor and figure out what numbers multiply to negative 24 that add to negative 2. I got negative 6 and positive 4. I'm going to go back and divide by what I multiplied by in the first place. That's my 3. I'm going to reduce, and I'm going to bring my bottoms up. And then I'm going to set each of my factors equal to 0 so I can actually finish solving. And I end up getting two answers, x equals positive 2 and x equals negative 4/3. Now be careful. Let's go back and double check that neither of those answers are part of my domain restrictions. And since they aren't, then both of those answers should work and be okay in that proportion. All right. Last one here, I have two fractions, again, set equal to 0, not set equal to 0, but set equal to each other. So I have a proportion. Let's double check to see what my domain restrictions are by setting each of these denominators equal to 0. And so it looks like x cannot equal 0. So anything should work except for 0. All right, let's cross multiply. I can do 3 times x and set that equal to 2 times 4x. I end up getting 3x is equal to 8x. I'm going to subtract 3 from both sides. When I subtract 3 from both sides, 3 minus 3 is actually a 0 on that left side. The equal to sign doesn't just go away. There's still an equal to sign and there's 0 left on that left side. So I have 0 equals 5x. I want to divide both sides by 5, and 0 divided by 5 is 0. But wasn't that one of my domain restrictions? And if I were to plug in a 0, either for this x or this x, doesn't that cause a 0 in my denominator, which we know we're not allowed to have? So if the only answer that I got was x equals 0, and we know that x can equal 0, then that really means that that's an extraneous solution, and we don't have any real solutions that would work. So on this problem, there would actually be no solution. So always, always, always look for those domain restrictions, and then make sure you double check your answer that it doesn't include any of those restricted values.